Welcome to a video on Chapter 2, Lesson 5. This is one of the first sections where we start looking at proof a little bit. In order to do proofs, we need to have certain rules that we can use to explain why we're doing certain things. So this is kind of the list that we might use in this lesson right now. Some are going to be kind of familiar. These first four just kind of tell us that it's okay to add, subtract, multiply, or divide by the same number on either side of an equation. These three down here are maybe a little bit new. We don't use them necessarily a ton, but the reflexive property just says that something is equal to itself. The symmetric property just says that we're allowed to flip-flop an equality. The transitive property is almost like the law of syllogism, maybe from some of the things we looked at with logic, where you have A is equal to B and B is equal to C. You notice that they kind of have the same parts. Here, you get rid of the B's and just say that A equals C. Sometimes we almost look at that like substitution, but there are times where they are slightly different. So substitution is another thing that we can do. We just replace something with another item that we know it's equal to. And then the distributive property, we send the A to both the B and the C in this case, and we can also do that backwards where we're kind of factoring. Then there's some terms that we might use as well, and we'll worry about those as we get to them. So just to kind of practice noticing some things, in this first example here, we're looking for what's happened as I go from 2x plus 9 equals 19, and it changes to 2x equals 10. And the difference here is I subtracted 9 on both sides, so our justification for being able to do that is just saying, hey, we are using that subtraction property. Here, I believe there's a little typo. This y right here should be an x. So if we start with x equals y and y equals 15, again we have kind of the same thing in common here. We can jump right from the x to 15 right away. So if this was x equals 15, that's kind of following that transitive property that we talked about a few minutes ago. You could also say here that we're just doing substitution. So that 15 is taking the place of the y right there. So in this case, there's kind of two answers. So just kind of be aware that we're allowed to do that. Notice too that with the way I write it, subtraction, I put a t there, substitution, I just leave like that. In example 3, we're just kind of flip-flopping the two. So here we're talking about the measures of angles. We start with E, and it's equal to t, and now we've just reversed them. That's the symmetric property from our table. And in this one, we have 3x plus 15. What I've done is I've factored out the common idea of 3. And basically, that's the distributive property. It's kind of doing that in reverse, though. It's factoring that common thing out. So one thing we want to be good at is just recognizing the changes from one step to the next and trying to see what property is allowing us to do that. So here's kind of our first official proof, probably the main one for this lesson. What they tell us is that angle AOM, which is the angle on the left here, and MOC are supplementary. And we're trying to explain why in the end x is 50. Now, right now, you could just plug a 50 in for x there and figure out what the numbers are and add up together and see if they are supplementary. We're just going to try to explain it maybe a different way. Or maybe we say, we don't know what x is. We better figure that out. We have to find that it's 50. So we're going to try to connect this to some of the if-then statements that we've been looking at. So if we start off by using this given, that if these two angles are supplementary, one thing we can say is that the angles have to add up to 180. So there's some notation things here. Now we're talking about numbers associated with the angle, so we put that little m in front. But if I add these two angles together, they should equal 180. And so the kind of our first column here is going to say, here's what we know. The second column is going to say, here's what we can then state about this because of what we had ahead of it. And then the third column is going to explain why. So in this case, well, it's because we knew what supplementary angles were. It's that definition. Okay, and then in our next line, we're just going to say, well, now I know that these two angles add up to 180. So the line that's right here is the same thing we had up there. It's going to seem a little redundant for just a little bit. But if I know that these two angles add up to 180, one thing I could do is I can go look at my picture and say, oh yeah, I know that angle AOM was 2x plus 30. And I know that angle MOC was x. So I'm going to put those things in place of these two statements right here. I'm going to put the algebra stuff that they're equal to. Well, what allows us to do that? We're just substituting. So we say it's the substitution property of equality. Okay, and then in our third line, we kind of take what we had as our then statement. It becomes our if statement. So if we now know this, again, all of these things, we've explained why they work. So if we know that 2x plus 30 plus another x equals 180, how could I simplify that last year in algebra? Well, we would have just combined the common things. So the 2x and the x become 3x. What allows us to do that? I don't know if there's a rule on the top part of our notes that really explains that clearly. So a lot of times in that case, I just say, hey, we just simplified. And that's fine to have that a few times. So now, if you knew that 3x plus 30 equaled 180, if that's the thing that we know, what would you have done last year in algebra to get closer and closer to knowing x? Well, you would have had to isolate the x. That means getting rid of the 30. So you're going to take 30 away from here and move it to the other side. You would end up with 3x equals 150. What's the property that we're using to do that? What's the algebra sort of idea? Well, we subtracted, so we're using the subtraction property of equality. And then the last thing that we would do is if I know that 3x equals 150, how do I get x by itself? I have to divide by 3. So I'm using the division property of equality, and now I have proven that x has to be 50. So I know that's a lot of writing for basically doing a very maybe simple algebra problem. The idea here, though, is to realize that in a proof, we start with the thing that we know. So if that's true, then what can we say and why? So we have one kind of linear progression there of this is the next thing I can say and why. Then I take that known thing, and it becomes, well, if I know that, then what can I say? And here's why I can say that. So it's just kind of a progression of here's what I figured out and why, and because of that, here's something else I can figure out and why. Okay, our last example, it's actually a pretty short thing to work through, but I just want you to be familiar with a couple of terms here. In this picture, they're telling us that 1 and 3 are the same, so we can see that with the red arcs right there. And they want us to show that the measure of angle AEC, so this larger angle right there from A to E to C, so basically 1 and 2 together, equals DEB, which is basically 3 and 2 together. So we know that 1 and 3 are the same because they told us that. The next thing I could do then is I could say, well, I kind of see where this is going. I can see that they both seem to have 2 in common, the angles that we're talking about at the end. So I'm going to add angle 2 to both sides. Okay. What allows me to add a number to both sides? Because that's really what the measure of angle 2 is. It's just going to be some sort of a number. Well, that's that addition property of equality. Okay. And then this is kind of the new thing. I just want you to get used to this. But angle 1 and angle 2, they make up angle AEC. And angle 3 and angle 2, they make up angle DEB, which are the two angles that we're trying to talk about. So if I know that these two things are the same, well, it kind of leads to that thing that we were trying to prove in the end. I just have to think about why. And this is going to be something that we've looked at a long time ago, but it's not going to be super familiar. That's called the angle addition postulate. And the angle addition postulate just says that if I basically am putting these angles next to each other, real close to each other, they're adjacent, and I want to add up the two smaller angles like 1 and 2, it's okay to do that, and now it can just be called the large combined angle, in this case AEC. So that's what the angle addition postulate talks about, and the segment addition postulate would kind of be the same thing but for segments. So that's it. We have explained why, if I start with this in this picture, it leads me to knowing this. So just a two-stepper. So I know this is kind of new. We'll just kind of see how things go. Make sure that if you have any questions or if things aren't quite making sense, that you have somehow noted that and can be ready to ask some questions.